Okay, so the next problem is mirror tree. Uh, okay, so this is like very similar to the problem that we did previously. The previous problem that we did was basically checking whether the left tree and right tree are identical or not. So this is doing the same thing, but like checking whether they are symmetric or not. So what is the difference between being mirror identical and being symmetric? Sorry, yeah, being identical and being mirror identical. So if I have a tree like this, one, two, three, four, five, six, seven, right? So what I'll check is whether this one is equal to this one or not. Whether this is equal to, like, when we see ourselves in the mirror, we see a reflection of us, which is sort of um, polar opposite in the sense that it is. um so if you see, I think this phenomenon is called something. I'm not sure. But basically, you see your left hand on the right side from your perspective. So the same thing you have to check in this case. The same concept as identical trees, but instead of checking the left of the first tree and the left of second tree, what you're going to do is you have to check the left of the first left subtree and the right of, which is this case, this is left of first subtree, and this one is the right of second subtree. So the same code, just let me just take an example to make this easier. 1 2 2 3 4 4 3. So we have this example: 1 2 2 3 4 and 4 3. So when you see it from mirror perspective, so you check these two, they are equal. You check this one, which is like closer, and this one, which is closer, and you compare them, and then you check this one and this one, right? So in the code, what you're going to do is you have to check whether they're identical, this part and this part, but you have to check them uh, in a polar opposite way, in the sense that instead of checking this with this, you have to check the left one of the first subtree with the right one of the second subtree, if that makes any sense. um, so you don't have to, like, in the previous case, this was if this was 3 and this in the first tree, and in the second tree this was 3, then this would have been called identical. But in this case, the left part, the left subtree has 3 um, as the first subtree of the root, and the second subtree has 3 on the right subtree, as the right subtree, 3 in the right subtree uh, as root. Then this will be called identical because they are like mirror opposite. So this is sort of mirror opposite. So previously what we were doing, we were like checking for null. The base case was simply if either one of them do not exist, then you just simply check if they are null or not. If there is some extension to it, right? So you simply check if they are equal or not. And a simple traversal. So this, in a simple case, in this question, what you will check is whether, first of all, whether the current root is identical or not, right? So this part. So the 2 is equal to 2 or not. Okay. So P's value should be equal to Q's value. But when it comes to checking symmetry or mirror identical, what you will check, sorry, we do not have P and Q in this case, and we will have to first um check, first send the left subtree and the right subtree. So for that, we will need a helper function. This will return some boolean, so let's call it helper function. And this will have the left subtrigger root and the right subtrigger root. So we will call P and Q because that has become sort of a convention for me at least. So I'll move this to here. So this will become helper, and we'll pass this. Now this will just return me a true and false because we are just sending the root. Sorry, we are not sending just the root. We are sending the left and the right subtrees of the root because we know the root is going to be same only, right? Okay. So the helper will be like this. So the left subtree of 2, like the left subtree of 2, 3, uh, this part will be compared with this part. So P's left will be compared with Q's right and vice versa, where P's right will be compared with Q's left, right? So this will tell me if they are like mirror identical or not. So yeah, this got accepted, and the space complexity will be same of n. Um, Maybe of n minus one. I'm not sure, but like of n minus one. Um, so let's try to analyze complexity. I think for a generalized view, of n will be there, right? Right, but I'm not sure if this is accurate or not. For the space complexity, same of h for the general case and of n for skewed tree.